Okay, today we will discuss how we will draw the layout diagrams for a NMOS technology and CMOS technology circuits. In previous class, we have discussed how we will draw the stick diagrams for a NMOS and CMOS technology circuit diagrams. Okay, so all of you know what are the different layers used in the stick diagram. The same layers are also used in the layout diagram. The only difference between the how we will draw the different layers in the stick diagram and how we will draw the different layers in a layout diagram. Now I will see everyone can see my screen, right? Okay, so these are the different layers. Already we discussed it in a uh, already the metal layer, how we will draw a metal layer in this layout diagram is in stick diagram we will draw just a lines, whereas in layout diagram we will draw like a blocks. In metal, how we will draw the metal layer in layout diagrams means here it is a metal layer. In this we will draw the block and straight lines for metal layer. And see the end diffusion layer, how we will draw the end diffusion, and the color used for metal layer is a blue. And how we will draw the end diffusion layer means here also we will take a these are the monochrome, how we will differentiate different layers using a monochrome. If we want to draw it in a color, we will indicate with a colors. So end diffusion means we will draw one box, and we will draw the lines, cross lines from top to bottom. Okay, so in p diffusion and diffusion we will use a color for and diffusion is a green, and p diffusion is also same like and diffusion, but the lines which are in somewhere in p diffusion we will draw that lines in a some we are maintaining a some space. So in n diffusion we will draw that lines very nearly, and p diffusion there is a we will give a some space in between line to line. It is a difference between n diffusion and p diffusion, how we will draw the n diffusion and p diffusion diagrams. And next one is a polysilicon. It is a diagram for a polysilicon. In polysilicon, we will draw the lines from bottom to top, cross lines from, whereas for N diffusion, we will draw the lines from top to bottom, whereas for polysilicon, we will draw the lines from bottom to top. Next, the polysilicon, we will use a color as red. For P diffusion, we will use a color as yellow. And implant same, whatever may be the in stick diagram we will use same symbol here also we will use for implant. It is a yellow for NMOS. And contact, what is our contact is in stick diagrams we will use a dot for contact, whereas here cross sorry square box with shaded for using a contact. The contact, for contact we will use a black color. And sorry, it is a contact cut. For buried contact we will use a square, and two crossed lines on that square we will use for buried contact. For buried contact we will use a brown color. And next one is a how we will draw the transistor diagram similar to the NMOS depletion mode transistor. In case of a transistor, NMOS transistor, for gate we require a polysilicon, for source and drain we require a N diffuser. For that purpose, clearly it is the first diagram is a NMOS enhancement mode transistor. In this we will use a N diffusion as well as polysilicon. For N diffusion, box and cross lines from top to bottom we will draw. Similarly for polysilicon, here in first diagram I have drawn a horizontal N diffusion, I have drawn horizontally, and vertically I have drawn a polysilicon. Similarly, we can draw horizontally, we can draw the polysilicon, and vertically we can draw the N diffusion. So it is how we will draw the NMOS enhancement. For NMOS enhancement mode transistor, we require two layers. One is a polysilicon and another one is a diffusion. For N diffusion, for NMOS enhancement mode, we will use a N diffusion as well as a polysilicon. So we can use horizontally N diffusion, vertically polysilicon, and vertically we can use vertically N diffusion and horizontally polysilicon depend upon our requirement. So the only difference between an enhancement mode transistor and depletion mode transistor is the implant is exists in depletion mode transistor, whereas that implant doesn't exist in the existing in a enhancement mode transistor. It is the only difference between enhancement mode and depletion mode. Whereas for PMOS transistor, we will use a P diffusion and polysilicon. The polysilicon is used for gate and P diffusion is used for source and drain. Similar to the NMOS transistor, in PMOS transistor also, we can draw P diffusion horizontally, polysilicon vertically, and vice versa, depend upon our requirement. So the P diffusion is like similar to the N diffusion, but the lines which are we will maintain as some spaces uh, between a line to line in case of a P diffusion. Similarly, we will draw the polysilicon also. So, and the only difference between PMOS enhancement mode transistor and PMOS depletion mode transistor is the implant existing in the PMOS depletion mode transistor, whereas implant doesn't existing in the PMOS enhancement mode transistor. I think now everyone can I think now everyone can know how we will draw the diagrams, the symbols in the layout diagrams. So, lobby lone, okay, just wait. Okay, I admitted everyone, those who have waited till now. Okay, okay, guys. What is the color used for metal? Yes, for blue color used for metal in layout diagram, we will draw the boxes, and for metal, we will draw the lines, vertical lines in that blue box. It is a symbol for metal. And the symbol for N diffusion is, for N diffusion, we will use a green color, and in N diffusion, we will draw the lines from cross lines from top to bottom. Okay, it is a symbol for N diffuser. And uh, and for P diffusion, we will use a yellow color, and for P diffusion we will use yellow color box, and the lines which here we will draw, we will maintain some distance between line to line. It is a P diffuser. Okay, and how we will draw the polysilicon means, polysilicon is, we will use a red color for polysilicon. And diffusion, we will draw a cross lines from top to bottom. Here we will draw the cross lines from bottom to top. It is a polysilicon. Okay, next for implant we will use a yellow color for NMOS. Implant is, it is a implant. And next one is a for a contact cut we will use a black color, and shaded in that box with a black color. Okay, and for contact cut we will use a brown color for contact cut. sorry, for buried contact we will use a brown color. So in this way we will draw the brown color for buried contact. Okay, these are the different layers how we will draw in a layout diagram. Now I think everyone can understand now how we will draw the different layers in a layout diagram. Now I will show how we will draw the layout diagram for a NMOS inverter. Okay, all of you know the diagram of a NMOS inverter. So I am drawing a first NMOS inverter circuit diagram of a NMOS inverter. For NMOS inverter, the pull-up transistor is a depletion mode transistor, and the pull-down transistor is a enhancement mode transistor. And here I will give a input in between pull-up and pull-down network. We will take a output. The upper line is a VDD line. The lower line is a ground. So it is a circuit diagram of a NMOS inverter. Now I will show how we will draw the layout diagram for this NMOS inverter. So all of you know for VDD and ground we will use a metal layers. For VDD and ground we will use a metal layers. For NMOS transistor a gate is a polysilicon layer. For NMOS transistor gate is a polysilicon layer, and source and drains are a and diffusion. Source and drains are and diffusion. Similarly the below one also NMOS transistor, so source and drain terminals are and diffusion, whereas a gate is a polysilicon layer. So these are the different layers, and uh, now here our drain is connected to the VDD. So whenever drain is connected to the VDD, here we require a contact. Similarly, this transistor source is connected to the next transistor drain. Here also we need a contact pattern. Here also the source is connected to the ground. Here also we need a contact. So for the now I will show how we will draw the layout diagram for this NMOS inverter. So first in any layout diagram, first we will draw the VDD and ground. VDD and ground are both are a metal layer. So I'm drawing here. I'm drawing it is a VDD, and I'm taking it is a ground. So for metal layer, we will draw the vertical lines in the box. In it is a NMOS inverter. So in NMOS inverter, our pull-up transistor is also NMOS transistor, and pull-down transistor is also NMOS transistor. So I can draw the N diffusion from top to bottom. Why? Because both pull-up and pull-down both are pull-up transistor and pull-down transistor both are NMOS transistors. That's why I will draw the from top to bottom I will draw the N diffusion. So here I will draw the N diffusion here. Here I will draw the N diffusion, and here I have to connect this N diffusion to the this metal of a VDD. For that purpose we will extend a N diffusion. Here also we will extend N diffusion. In that we have to give a contact. So whenever here N diffusion and VDD or N diffusion and metal are connected, we have to give a contact. Here also n diffusion and metal are connected, that's why I am giving a contact cut. And it is a n diffusion, so we have to draw the lines from top to bottom, cross lines we have to draw it very near. Okay, and next we have to draw the polysilicon for gate. For that purpose, the pull-up transistor is a polysilicon. I am drawing a polysilicon, and this gate is connected to the our gate is connected to the drain. For that also, I am giving it. Now this polysilicon gate is connected to the drain. For polysilicon, we have to draw the lines from bottom to top. And we have to give a contact. Wherever there is a connection, we have to give a contact cut. Okay, now and it is a depletion mode transistor. For depletion mode transistor, we have to give a implant also. It is the only difference between enhancement mode and depletion mode transistor. For depletion mode transistor, we have to give a implant also. And then pull down transistor, we have a one NMOS transistor. We have a gate. At gate we okay, okay. Now for pull down transistor also we have a gate. For gate we will give a lines from bottom to top. Okay, here I am giving a input X. Next we are taking a output in between a I am taking a output in between a pull up and pull down network. Pull up and pull down network మధ్యలో and diffusion ఉందాం. So we can directly take and diffusion, and here we can take a output. Otherwise we can connect one metal to that and diffusion, and we will take a output from that and diffusion. So it is my output y. I think everyone can understand now. It is also similar to the stick diagrams, but there is a difference in a layers. In layout diagram, we will draw a boxes, layers like a blocks, boxes, and some lines in between that boxes. So it is a layout diagram of a NMOS inverter. Similarly, now I will show you how we will draw it for a CMOS circuits. Now let us consider if I am taking a CMOS inverter. How we will write for a CMOS inverter? Let us consider it is a circuit diagram of a CMOS inverter. In CMOS inverter, pull-up transistor is a PMOS transistor and pull-down transistor is a NMOS transistor. It is a NMOS transistor. In between pull-up and pull-down, we will take a output. Similarly, here we will give a input. The above line is a VDD line and the below line is a ground line. Now I will show how we కనబడట్లేదా అసలు స్క్రీనే కనిపించట్లేదా డ్రా చేసింది కనబడట్లేదు కనిపించ CMOS ఇది కనిపించట్లేదా? డిలే ఏమైనా ఉందంటారా? ఓకే, ప్రెజెంటేషన్ స్టాప్ అయింది కదమ్మా. Now I will- now everyone can see my diagram. Okay, it is a CMOS inverter circuit diagram in which what are the layers used for VDD and ground? For VDD and ground, yes, the metal layers are used for VDD and ground. And what is the layer used for gate of a PMOS transistor? Polysilicon. Gate of a NMOS transistor is also polysilicon. For source and drain of a NMOS transistor, we will use a N diffusion. For source and drain of a PMOS transistor, we will use a P diffusion. Okay, so these are the different layers used for layout diagram of a CMOS inverter. Now I will draw the layout diagram of a CMOS inverter. For this CMOS inverter, first we have to draw the VDD and ground. For VDD and ground, we will use a for VDD and ground, we will use a metal layers. Blue color is used for metal. Okay, after that we have to draw the demarcation line in case of a CMOS. Like our stick diagram, here also we have to draw the demarcation line. This demarcation line, the above this demarcation line is a pull-up network. The below this demarcation is a pull-down network. The pull-up network we will use a PMOS transistor in a pull-up network. In pull-down network we will use a NMOS transistor. So first I will draw the pull-up networks. In pull-up network I will use a PMOS transistor. So for that P diffusion I will take a yellow color, and the lines here we will maintain a some distance between these cross lines. It is a difference between PMOS and NMOS. And after that PMOS, in below is a okay. Now I will draw the for PMOS. I am writing a gate for PMOS transistor. It is a polysilicon. For polysilicon, we have to draw the lines, cross lines from bottom to top. Okay. Now the pull down network, in pull down network we have a N diffuser. Sorry, we have to draw the contact for uh, P diffusion and metal. Similarly, in N diffusion, the pull down network is a N diffusion. Okay, so N diffusion, top to bottom. And here also whenever the connection between two layers occurs, we have to give a contact set. Okay, now again for this NMOS transistor also we have a gate which is a polysilicon. Now I have drawn PMOS transistor in a pull up and NMOS transistor in a pull down. Okay, now I have drawn PMOS transistor in a pull up and NMOS transistor in a pull down. So sorry, for uh, polysilicon we have to draw the lines from bottom to top. Okay, now I have to draw the connections between these two transistors. Now these two transistor gates are connected together and I have given an input. Okay, these two transistor gates are connected together and where I have given a input. Okay, now these two transistor gates are a polysilicons. Okay, so two are polysilicon, so I can extend this polysilicon for connecting two polysilicons. I can extend this polysilicon. For polysilicon we have to give a lines from bottom to top, and at this polysilicon I have given a input. So for input I have extended my poly, so here I have given a input. Now where I have taken a output, for a pull up transistor, source is connected to the drain of the pull down transistor. So this source is connected to the drain. The source is a p diffusion and this drain is a n diffusion. That's why we have to connect a one metal. Whenever two different layers exist, we have to connect a metal. So for connecting a p diffusion and n diffusion, we have to connect a metal is used for connecting this p diffusion as well as n diffusion. The metal is used for connecting a between p diffusion and n diffusion. Wherever there is a connection, we have to give a contact touch. Okay. Now I can extend this metal where the source and drain terminals are connected, where I have taken an output. So for that purpose, I will extend this metal and where I will take a output. Okay. So it is a VDD and it is a ground. Okay. Now I think everyone can understand how we will draw the layout diagram for CMOS technology also. Anyone having any doubts for drawing this layout diagram in NMOS and CMOS technology? Okay, all of you draw the circuit diagram for NOR gate using a NMOS and CMOS technology, and also draw the layout diagrams. All of you draw the layout diagram and circuit diagram for a NOR gate using NMOS and CMOS technology. NOR gate. అవసరం లేదు మోనోక్రోమ్ డ్రా చేయండి అమ్మ. If you don't have a color pencil, okay, I will show you the layers.